Hey guys, and welcome to episode 4 of How to Program in C++. Today we're going to be going over one more thing on identifiers, and then we're going to get moving with some more data types. So you can store other things other than just a regular number without a decimal in it. So, let's get started. First thing I wanted to talk about was the identifiers thing, and basically what I wanted to say is you cannot make your variable's identifier a reserved keyword. Now, what is a reserved keyword? Well, it's a keyword reserved by the compiler that has some kind of function. For example, the ones that we have used so far are using, namespace, and return. If we try and name our variable, for example, using equals 4, the compiler will just not know what's going on. It does not understand that using, you're trying to say that using is the identifier. It's trying to use the function that using has behind it. So that won't work. So watch out for that. If you want a full list of reserved keywords, because there's a lot of them, then go to this website. It's www.cplus.com/docs/tutorials/variables. If that I went too fast for you there, then you might want to look at this and copy it out. I'll try and put this into the description if I remember. If not, then I'm afraid you're just going to have to type it out. This website is really great. If you prefer the reading through tutorials, then I definitely recommend this as a method for learning. Anyway, moving on, there is a huge list here of keywords that you cannot use. And also another little list down here of some extra keywords which represent operators. But we'll get on to operators later on. So for now, just know that you cannot use these words and you cannot use any of these words. So that's important. If you're having any issues, then that could be why. So, moving on, data types. Let's talk about them. So right now, the only data type that we know about is integer. And as we know, an integer can store a very large number without a decimal point, and it can be negative. What if we want to store a number with a decimal point in it? Well, if we try and just add a decimal point to our integer, say 3.84, and run it, it will just chop off the values after the decimal point. It will just ignore everything after the decimal point, which is a bit of a bummer. It won't even round it for you. It will just chop it off, which can be abused later on. So we'll talk about that more later. But for now, let's talk about the data type which will allow us to store decimals. And that data type is a floating point number. The way you write the word for this is float. And so you just define this variable exactly the same way that you did with the integer. Give it a name such as cans and set it equal to whatever you want. So in this case, I'm going to set it to 3.5 just to demonstrate. It's as if you have one can that is split in half, I guess. So let's see this so we can see if it's working or not. And hopefully it is. Otherwise, something has gone terribly wrong. Let's build it, and yes, now you can see it is outputting 3.5 rather than just 3. Now, there is another data type that you can store a floating point number with, and this is called double, which stands for double precision. Let's make bottles equals, say, 4.63 and semicolon. Now, the reason why you might want to use double over float is because it has far greater precision, almost twice the amount of precision. However, a floating point number should be just fine for anyone. It stores a large number of significant figures, so it's really not a big deal. You're only going to need a double if you're storing very precise things like maybe time, and you want things to be absolutely perfect. However, doubles are really easy for a 64-bit computer to process. So nowadays, you'd be fine with using either. You wouldn't really be wasting processing power or memory very much using doubles instead of floats. It's just kind of a thing that computers have grown better at dealing with. Now, the problem with this, with me demonstrating this, is as soon as I type cout bottles, colon, 2 arrows, bottles, and line, you'll notice that when I run this, they will both be to the same amount of precision. And this is because when you use cout, it's gonna give you the exact amount of precision regardless. It's not going to give you the amount of precision stored, it's just going to give you the amount of precision that it decides, which is a bit of a pain. It means I can't prove to you that the double is able to store more figures, but you're just going to have to take my word for it. The double is far more precise. Now, what if you wanted to make a variable that just has 2 states, on or off, or 1 or 0? You can do that using the Boolean data type, which is written as bool in C++. So let's make one. Let's call it has cat. I don't even know why. And set it equal to false, because I do not have a cat right now. Now let's see out this and see what it gives us. Has cat is equal to has cat and line, semicolon. Let's run it, and as you can see, it outputs a 0, because the way that it is stored, it literally just stores a 1 or a 0. False is pretty much just another representation of 0, and true is basically another representation of 1, as you can see. You could just enter in 1 or 0, but it's far more readable to enter in true or false. If you try and give this a number over 1, then it will just print out 1. And that's it for that. One thing that I want to quickly note, because I've kind of drifted over it, is the fact that I have named this variable in this way. I've used this kind of naming scheme. Now, you can use whatever naming scheme you want for your variables, but I find sticking to one in particular is a really good way of keeping your program clean and making it easier on yourself. Now, whenever I use multiple words in a variable name or identifier, I always make the break between words, the first letter of a word break, a capital. That was a really weird way of saying that. Cannot talk today. Sorry about this, guys. So if I wanted a variable called green apples, instead of just calling it green apples with a space, because that would be invalid, I have to call it green apples with a capital. Now, some people prefer to indicate separate words by using an underscore. This is perfectly acceptable as well. There are many, just whatever works for you, as long as it's consistent, it's fine. Consistency is the most important part, so you don't get caught out later at a later point. Okay, let's go over one more fundamental data type for now. It's really, these are the 5 most important ones, at least early on. So, we're going to go over one called character. Now, the way you write this in C++ is car, and let's call it pairs equals 43. Now, a character can store any value between 0 and 255. It cannot, however, be negative. Up until now, both the double and the float could be negative. Boolean, however, could not be negative. So these are kind of a pair in that way, that neither of these can be negative, by default at least. So, let's try and see out this car. And you will see something funny will happen, which I'll try and explain in a second. And line, and then let's execute it, and you'll see that pairs has a little plus there. That's a bit funny. What if I enter in 65? That's come out as A. Now, any of you that know ASCII would know that that's what these numbers that I'm putting in represent these characters that I'm getting out on an ASCII table. This is because when cout tries to output a character, it thinks, oh, this person's trying to output the actual character that this number represents. I'll change it to that. So that's why that happens. You can get around this by casting it to another number, another data type, such as an int, but we're not going to go over that yet because casting is in the future. The only thing you should know right now is that although cout is outputting an actual letter, any other arithmetic or in any other situation, using a chara is perfectly acceptable for holding numbers. So just know that. So that's going to do it for this episode. That's quite a lot of information for you to take in all at once. We will be reusing all these data types at different points. So you don't need to know these off by heart right now. I thought I'd just give you an early explanation on what these do, just so you could get ahead of the game. Whenever I use these, you will know what's going on. But trust me, if you don't know them now, you will learn them as we go along. Okay, guys, that's going to do it for this episode. Thanks for watching, and I'll see you next time when we will go over some specifiers.